recording so Ivan can see. So real quick, just so everyone knows, date, it is not 11-2, silly Mr. Hudson, it's 12-2. We're doing 4-2-2 today. Ivan, we miss you. We'll drop a code word in the video later to see if you actually watched the video over the weekend. Any questions on like probabilities? We talked a lot about proportional relationships having that 0-0 point and then going up consistently, Addie. You what? You weren't supposed to. So that's not my problem. But if you turned them in before, like yesterday or whatever, they might be in my folder of things to grade. Oh, well, why'd you do that? You want to check it before you turn it in. Always want to check it. I mean, if you checked it on Schoology, that's fine. Like, as long as it's already been checked. I do. The new kind, like the flat kind. Yeah, if you already checked it on Schoology, you can leave it in there. Anyone else need a charger? You guys, you can go ahead and open your Chromebook up because we're going to be limited on time today. It's like, go ahead and get it, like, heading towards Desmos. And if you need to charge, then we can get you a charger. Any other questions on 4-2-2? Otherwise, we want to make sure we turn things in so we can beat Accelerated 7. Guys, they have to turn in 6 assignments today.
Oh, yeah. You guys only have 3.
You only have 3. So it's like twice as manageable for you, or like half as difficult, or whatever proportional relationship you want to give it. Margot! I don't know, Margot.
Oh my goodness.
Something made the floor wet. Something broke the stereo. Like how half the people in here are like, what the heck is... Yeah, it's, Margot, would you like to... It's what? It is Christmas Vacation. National Lampoon's Christmas Vacation. Some of the humor's too dry for kids. All right, if there's no questions, we can move on into the lesson. Get out 424 if you don't have it out. I forgot to put it up here, but it's kind of obvious that you'll need today's worksheet. Turn in your homework. Turn in your homework. If you didn't turn in your homework, please turn in your homework. So guys, just to clarify, like if Ivan never shows up today, he doesn't count towards the homework competition because he can't turn in his homework. But that doesn't mean like be sick on Fridays or whatever. That's silly. Don't do that. Just do your homework. Turn it in. Because he'll still have to turn it in on Monday or Tuesday or whenever he gets back. I need a copy of 424 to fill out for Ivan. So you've got this table on your paper that says like this is your practice work. So like this I forgot all of this is practice work. So actually if you just want to go ahead and stick this back in your binder, what do we need every single day? Graph paper. And that's going to be really important today because we're learning a new vocab word. We're learning a new, it is not sleigh. I had to learn that vocab word though, as I like, you know, like no cap and sleigh.
Yeah,
all these
no
vocab
cap.
words that I have to learn to stay hip
Go
with the
cap.
kids. It's vocab. It is. It's like vernacular vocab. 'Cause, like,
Mr. Hudson.
you guys inventing new words that don't need to be invented is cringe to me. So there you go. Anyone want to read? Anyone want to read? Jana, go ahead and read this paragraph for us, please. Hey, Jana's reading. We're listening. Jana's reading. We're listening.
In previous lessons, you studied different ways to
Be real loud, Jana.
In previous lessons, you studied different ways to represent proportional relationships. You organized information into tables and graphs. You also wrote equations modeling the proportional relationship. Proportional relationship equations are the form of y equals k x, where k is the constant proportionality.
Yeah, this weird word is what we're going to end up writing down if you want to write while Jana's reading. But go ahead and keep going, Jana.
Today you will find the connections between different representations of the same proportional relationship. Explore each representation more deeply and learn shorter ways to go from one representation to another. As you work today, keep these questions in mind.
So, how can we see the growth in the rule? How do we know that our rule is actually correct? Because it's real easy to write down a rule and say, here's a rule. It's not actually right. What does the representation tell you, and what are the connections between a representation? So on your graph paper, what I want you to write, please, is y equals kx. And you can either put the multiplication dot or you do not have to, because a letter right up against another letter is multiplication. At least if we're not in the language arts room. Where are my pens? That k, I know, this is going to bother some of you. That k is what we call the constant, but it's spelled with a C. Like, because constant is spelled with a C, but this is what we call our constant of proportionality. So I'm only going to ask you to write that word like probably this one time and maybe a couple more, but like not much. I'm already misspelling it. Thank you. Proportionality. So I'll give you a moment to try to get that spelled right because it's weird. Like personality. So guys, what that constant of proportionality tells us is how y is related to x. And we often talk about y as our output. So if you want to go ahead and label output, please, it will help you, especially like when I let you use your notes on the test. And the x, well, if y is our output, what do you think x is?
Our answer.
If there's an output, what would we need to... There's an input. So x is our input. Like
Hyperbole.
a million times. Ooh, hyperbole.
I was just about to say
Miss
that.
Hassanin would be so
Miss
proud.
Hassanin, they're learning.
She would be so proud of you guys.
So if we come back up here to this question, Graham earns $4.23 for each half hour of work that he works. Guys, if you're going to get a job, do you think they're going to tell you what they're going to pay you every half hour?
No.
No, so turn to your neighbor and make more sense of this problem they just gave us. What do you think they're actually going to tell you they're going to pay you? Like, what is that pay actually going to be?
I don't know what you guys think.
Well, actually, you can join our table.
There you go.
Like,
That's nice.
join it.
Join us, June says.
Join the
So,
She's like,
join us.
Mr. Humphrey.
So,
Did it. Nice, good
they
work.
would, yeah,
Cards.
they would,
Made a whole lot of progress.
they would give you the
Wow.
amount per hour.
Addie, what did you and Margot talk about? That company would probably actually say to you. Yeah, what they'd actually be paying you if we double that, because from half an hour, if we do times 2 to the money and times 2 to the time, that's going to give us $8.46 per 1 hour. Yeah.
If you also knew how many hours a day you were working, you could figure out how much they were getting paid.
So then, Margot says, if we knew how many hours we were working, so let's make a quick little table on our graph paper, because guys, this is going to prep us for our Desmos activity. Let's go and say that hours is going to be our input. How many hours I work determines how, actually, well, not for me. Does it matter how many hours I work? Nah, I don't get paid by the hour. Right, Ms. Mark doesn't get, none of us get paid by the hour. We get paid what's called salary,
What's your
which
salary?
means do your job. You can look it up. It's like 70.
you can find it.
It's like 70 grand or something for the whole year for all your work responsibilities.
It's like 70 grand for a day.
That's not, no, for a year. For the whole year
And I make
responsibilities.
less than that, so.
That's not right.
So, if we work 1 hour, we would make what did we say? 8.46. Well, wait a minute. What if I worked 0 hours? And you guys don't have to like.
get any money.
Yeah, if I worked 0 hours, if I don't show up for work, so we have that 0 point. You don't really have to put. So this is proportional, How could I calculate in a day we work 8 hours? How could I figure that out, Moss?
You just do 8.46 times.
Ooh, Moss said just. That's like one of those bad words. So if we do times 8 over here, we got to do times 8 over here. So Moss says take your 846, do times 8. Go ahead and do that. Grab a calculator, make it happen. And then figure out what if we work for 40 hours, because that is a week, right? Most people work 40 hours in a week. Let's calculate that one as well. You have the 8 hours for me? 67.68. So in a day, Graham makes about $67, maybe 68 if we round up. How could I go from 8 to 40?
Multiply by 5.
Ooh, multiply by... Why is that? How many days do you normally work in a week? You normally work 5 days, depending on the job.
Yeah.
Right? Like, a lot of times your first job, you'll work on the weekends, and maybe not on a couple weekdays, because you got sports or something else. So if we take how much I can make in a day, right, that 8 hours, and do times 5, how much can Graham make in a week? Alex?
You can make 169.
169 point what? 2, but if it's dollars,
$169.02.
2 cents? 20 cents. Yeah, be careful with that. That would be $169.20. So guys, what we could say here for Graham is his pay. If we want to make a relationship that makes more sense, his pay will equal 846 times what? What determines how much he gets paid, Lindy?
Why the question?
Yeah, go ahead.
When you do it in money, like why do you add a 0 at the end?
Because we always have 2 decimal places for money.
Okay.
Because if we only put the first decimal place, it's tricky of is that 2 cents or what is that? If we put the second decimal place, we clarify, oh, it's 20 cents.
So if it's 2 cents, would you put it in the
It'd be
second?
0.02, right? Yeah, then it'd be 02.
Okay.
So it's $8.46 times, what do we multiply by? What determines how much he'll end up making? The hours. So our input here is how many hours. Because you don't have to use y and x. You can use other variables.
Like W and L.
So, like, if we start thinking about up, and anyone who got here late, like, we watched some of the up, the equation he's probably thinking of is, like, the lift that you could get, the lift equals something times, like, the number of balloons. Right? Like, you can make any equation you want. The dog food I need to buy is equal to whatever my dogs eat. Like, I can make any proportional equation I want, because if my dogs are going to eat for 0 days, they'll probably eat 0 food. But the more days they eat, the more food they eat. And that's why I have auto ship, right? Chewy automatically sends us our food. Let's get on Desmos.
Yeah.
I love Desmos. Fridays are short. Let's get on Desmos, because I think this will help solidify this idea that we're talking about.
I'm positive.
Yes, Raphael.
Please, Raphael.
I will Give me a moment, man.
Patient.
So, since I don't need you to turn up your volume, here's the first slide. We'll play it together.
By helium balloons. A Calgary man flew upward into the sky last night on a chair.
Here, we'll watch it again.
Lifted by helium balloons. A Calgary man flew upward into the sky last
Who's the
night
lady screaming in the background?
All right, so go ahead and start. Probably his wife.
Yeah, that's like on his way.
Maybe she's like, I have life insurance on him.
I got my question down.
All right, I'm looking to see everyone getting into Desmos. Ivan, at home, you should still be able to get into the Desmos. Ivan, let's make your secret code word up. Let's just make that your secret code word. Do you guys think up could actually happen? Like you could lift a house with balloons?
Well, no. Probably maybe if you have like a bunch.
Ooh, if you had a bunch.
Maybe if your house was like really small.
Ooh, or if you made like a fake, like small house.
Or if you had like a plastic house, a toy house, and then
Like the dog houses?
yeah, just why? Up and away.
Guys, please turn in your homework. I heard Accelerated 7 people asking each other out there in the family, like, hey, is your homework done? Hey, is your homework done? Like, they're trying to band together, but it should be more manageable for you. June, you getting in there? Margo, Donovan, do you guys need any help? Okay.
No, sorry, I was looking up how many helium balloons it would take to blow that up.
We can figure that out. Don't look it up. We can figure it out. I got another extension cord, Moss, if you like. I can bring it from right back there. No, just sit back where you are.
It'll
I
fit
got
back
you.
there.
Come on, I might not be a tech guy like Estes, but I got some skills.
Yeah,
I bring all of it up. You're right, there are no outlets over here, so that's why I got the long extension. Alright, so we quickly decide, since we accidentally let the ducky fly away, that we don't want to necessarily make things fly away. We just want to make it float. Okay, so once you get into the activity, you'll see your goal is actually how many balloons to just get it to float. Like, which would be really cool if we could just, like, have somebody floating around in a chair. Like,
That would be really fun.
like, yeah, just like a round Phoenix or whatever. Like, flying away would be kind of scary, but floating would be kind of cool.
Tie the duck to the ground.
We should have thought about that first.
Right.
We didn't.
What about that man? Like, how did he get that?
He
Pop balloons.
pop them and then like
See,
roll
Pop
it.
one balloon at a time, and you'll start
I mean,
coming
like-
back down.
But what if? I don't know. What if he
Well, how did he get back down? 'Cause if you
All right,
pop
I
it,
was gonna hold. I was gonna wait a bit long. Well, actually, I need to because my recording. How long are we in here?
9:20.
I might as well go. All right, Ivan, I'm gonna shut down the recording because the video I'm about to play is not mine.